Electric motors. Now, electric motors are used in many appliances like in refrigerator, in TV, in mixers, washing machine. These electric motors have made our life much more easier. So, what are these electric motors? So, these are the device which converts electrical energy into mechanical energy. But how do they work? So, the electrical motors, they work on the principle that is current carrying conductor which is placed in a magnetic field and this experiences a force. Now for this construction we require an armature coil, that is the rectangular loop of the copper wire which is having resistivity coating. Then we require a strong magnet. So the armature coil is placed between the north pole and the south pole of the magnet. Then we have a split ring, that is the two halves of the ring X and Y you can see in this picture. So they have resistive coating on the inner side and the conducting surface on the outer side. Then we have carbon brushes. So these are two stationary carbon brushes, that is E and F. In the picture it is named as E and F and are connected to the outer side of the split ring. Then we have a battery. The battery supplies the electric current to the armature coil. Now how does it work? So when the circuit is completed, the current flows from point A to B through the carbon brushes, that is E and F. So from E and F, the current goes to A and B. Now since the direction of magnetic field is from North Pole to South Pole, so according to Fleming's left hand rule, a force is exerted on the branch of AB, that is in the downward direction, and CD, that is in the upward direction. So because of the downward and the upward direction of the current, a loop and the axle starts rotating in an anti-clockwise direction. Therefore, a force is exerted and the loop continues to rotate in the anti-clockwise direction. So after half rotation, the current in the loop starts flowing in the direction of the DCBA, and this is how it keeps moving. So we can conclude by this that the current in the loop is reversed after each half rotation and the loop and the axle continue to rotate in the anti-clockwise direction. Now, electromagnetic induction, now this was given by Michael Faraday in the year 1831. And we have also learned about the electromagnetic induction in Towards Green Energy Science 2 chapter, in which we had seen that whether you move the conductor or you move the magnet, in both the cases the current is produced. So the same principle was given by Michael Faraday only, that an electric current can be produced in a conductor with the help of the moving magnet also and with the help of a moving conductor also. So Michael Faraday gave a law of induction, and the law states that if the number of magnetic lines of force passing through the coil changes, so the magnetic lines which are passing through the coil, it keeps on changing continuously. So the current is induced in the coil, and the current which is produced in the coil is called as the induced current. So by Michael Faraday's law, we can come to know that the current can be induced in a conducting loop if it is exposed to a changing magnetic field. So this change may be produced in several ways. So what you can do is you can change the strength of the magnetic field, you can move the conductor in and out of the field, or you can alter the distance between the magnet and the conductor, or even change the area of the loop which is located to stable the magnetic field. So no matter how much variation you do, the result, that is an induced current, is always same. So the strength of the current will not vary. That is the current, that is only induced current will only form. You do whatever you want to do. Now Fleming's right hand rule is used to find out the direction of the induced current. So again, now here what we have to use our right hand. Now what we have to do is that we have to stretch the thumb, the index finger and the middle finger of our right hand in such a way that they are perpendicular to each other. Now what these indicates? Now your thumb, that is your stretched thumb, it indicates the motion of the conductor. Your index finger indicates the direction of the magnetic field, and your middle finger now indicates the direction of the induced current. So this was the rule which was given by Flemings, and this is called as the Fleming's right hand rule, and through this we can easily identify the motion of conductor, the direction of magnetic field and the direction, especially the direction of induced current. Now electric generator. So a generator, it converts the mechanical energy into electrical energy in the form of AC current, that is the alternate current. Now current can be of two types, that is DC and AC. So this type of generator, they convert the mechanical energy into electrical energy in the form of the alternate current. Now, the principle for the working of this type of generator, it works on the principle of electromagnetic induction only. Now, what things do we require for this? We require an armature coil, that is a rectangular loop of copper wire. Then we require a strong magnet, that is which will have north and south pole. Then we have the slip rings. The end of the armature are connected to the conducting rings, that is R1 and R2. You can see in the picture here. So these are the slip rings, and now these are also fixed to the axle, which the resistive coating in between the ring and the axle. Then next we have the carbon brushes. This is the stationary carbon brush, that is B1 and B2, which are connected to a galvanometer down, you can see. Then we also require the galvanometer, that is it detects the presence of current in the circuit. So when the armature coil, that is ABCD, is rotated by an external force in the magnetic field, so it is provided by a very strong magnet. So it cuts the magnetic line of forces. Thus, the changing magnetic field is induced, and the current, that is the current which is there in the coil, it is the induced current. Now, after the rotation of the axle, that is the arm AB, it moves upward while arm CD moves downwards. And therefore, ABCD rotates in a clockwise direction now. Earlier it used to rotate in anti-clockwise, but here it rotates in a clockwise direction. So as per Fleming's right hand rule, the current is induced in the coil and the flow of current will go from A to B and C to D. So the current is flowing in the direction of ABCD now. So the current flows from B2 to B1 in the first half of the revolution in the external circuit, and after the half revolution the arms AB and CD exchange their position, and due to this the induced current flows in the direction of DCBA now. But the arm AB is in contact with B1 through a slip ring and arm CD is in contact with B2. So in the second half of the circle, the external circuit, that is the electric current, flows from B1 to B2, that is in the opposite to the previous half rotation. And this repeats after every half rotation, and alternate current is produced through this manner.